Hi, in this video I will show you how I perform different types of relative compression tests on a Honda engine equipped with 4 spark plug wires.
Lately I bought another budget oscilloscope. I used it to fix my old Hantek oscilloscope and also to fix my current probe. This oscilloscope is made by Fnirsi and the model is 1013D. Because the company name can be pronounced differently, I will refer to it as the 1013D scope. Since I wanted to perform some compression tests on the engine of my classic Honda DelSol, I decided to use my scopes and compare the results. I know my scopes are very limited compared to the picoscopes, but they are good enough for my basic needs. My Honda vehicle was equipped with a distributor and 4 spark plug wires. In addition to my oscilloscopes, I used my ignition probe, my current probe, and a small laptop to perform the relative compression tests. I made these diagrams to show how I wanted to connect the tools. My 65 amp current probe is also commonly called a low amp clamp. The first range is used to read from 10 milliamps to 20 amps, and the second one is usually used to read from 20 to 65 amps. One requirement about the low amp clamp is that the size of the battery cable must be smaller than 9 millimeters in diameter in order to fit properly between the jaws. So to do it, I just need to connect a small jumper wire to one of the two battery posts and the other end of the jumper wire somewhere on the corresponding circuit. A small jumper wire carries less current than the original battery cables, therefore less amperage. With my vehicle, it was not possible to install it on the positive cable, so I used my homemade dual jumper kit. I connected it between the positive battery post and the positive terminal connector. I selected 1 mV per 10 milliamps because with the starter motor, the small wire carries less than 20 amps. If the waveform needs to be inverted, I can change the direction of the wire in the jaws, or I can select the invert function of the oscilloscope if it's available. I also clamped the ignition pickup probe onto the spark plug cable number 1 to display the reference spike of the ignition waveform. The spike is used to indicate the beginning of the firing order. Before cranking the engine, I unplugged the 4 fuel injector connectors to prevent the engine from starting. During the procedures, the transmission shifter was in park position and the parking brakes were engaged. Usually, a relative compression test requires an assistant to crank the engine, but I was alone when I performed all the tests. First, I placed my Hantek scope and the laptop on the table beside the vehicle. So, I had the possibility to see the waveforms while I was cranking the engine. The ignition probe connector was connected to the BNC channel 1. I selected the auto mode and I adjusted the time divisions to 200 milliseconds per division. The clear float mode is not available with this engine, but holding the gas pedal fully depressed when cranking is still okay to stabilize the compression strokes. Next, I cranked the engine. The camera was also filming the waveforms. At 200 milliseconds per division, the waveform was fully displayed in sweep mode, at every 2-second intervals. This video screenshot shows the waveform when I began cranking. The second screenshot shows it in the middle of the cranking. And the third screenshot shows it at the end of the cranking. Then I disconnected the Hantek scope. Not long after, I connected the 1013D scope in front of the steering wheel. I adjusted the time per division and the voltage output values. Note when the selected time base is between 100 milliseconds and 50 seconds when auto is selected, the slow sweep scroll mode is activated by default. The setup was basically the same as the one I used with the Hantek scope. At 200 milliseconds per division, the sampling rate that was generated during the scroll mode was not adequate enough to properly display any precise information. So I changed the time divisions to 100 milliseconds, but the shape of the waveform did not improve at all. Then I tried 500 milliseconds, and still I was not satisfied with the waveform. The downsampling seemed far too low to generate a usable waveform. After, it was time to test the dead cylinder with the Hantek scope. I removed the spark plug from the cylinder number 3. Based on the firing order 1342, the compression stroke of the cylinder number 3 follows the compression stroke of the cylinder number 1. So it should not appear in the following waveforms. Again, I used screenshots from the video to better show the effect of a dead cylinder on the waveforms. To me, the waveforms were accurate enough to easily see the humps of all compression strokes, except the ones from the cylinder number 3. Later, I didn't even try to test the 1013D scope with the amp clamp to show a dead cylinder waveform, because I was not satisfied with the waveform I had seen before. On the other hand, I didn't try to display the voltage drop during the compression strokes with the Hantek 6022BE, because it doesn't have the AC coupling function. Therefore, to see the voltage drop of the battery, I used the 1013D scope. I connected a regular scope probe to the battery poles. I used the channel 2 and the coupling was set to AC to better display the waveform of the voltage drop. This waveform shows the small voltage variations during the cranking. When I compared this waveform to the ones I did with the low amp clamp, this one was showing a rough definition of the compression strokes. To me, this waveform was barely acceptable, but nevertheless, I decided to remove the spark plug number 3 again to try another compression test with a dead cylinder. As expected, this waveform was not very precise, but it was possible to determine that the cylinder number 3 had no compression. Both oscilloscopes have good and bad points, considering their low retail price. The Hantek scope worked fine with the low amp clamp and the ignition clamp, but it didn't have an AC coupling function to be able to properly read the small variations in the 12-volt range. Even though the waveforms were easy to analyze, it would have been useful to have a noise filtering function. The 1013D scope displayed jagged waveforms with the amp clamp. And when I tested the voltage drop from the battery, there was just enough definition to identify the humps, but not enough definition to confirm compression drops around 10 or 15%. The scope has AC and DC couplings, but it cannot invert a waveform. Overall, I was disappointed with the sampling rate outputs when the time divisions were long. The Hantek 6022BE doesn't have a filtering function, but even without it, I preferred it to analyze the waveforms of a relative compression test. Still, the 1013D scope can be useful with other applications, because it is portable and it has the AC and the DC coupling.
These two oscilloscopes are only basic tools, so if you need more processing power and more options, it is better to buy a professional automotive scope.